Hi everyone, I'm Trevor with North Valley Search and Rescue. Today we're going to explore another video in our rope rescue series. As always, this video is for use in conjunction with professional training for North Valley Search and Rescue within the scope of our SOPs utilizing our equipment. This video is not a comprehensive training package, but rather a small component of training and should be used under the guidance of a qualified professional trainer. There are many methodologies and avenues to achieve a desired outcome, but paired or performed incorrectly can result in injury or death. All ratings discussed are with new, fully rated equipment under perfect conditions, which never happens. Used equipment, time, UV exposure, use, application, or any other condition or alteration will change the load capacity. All ratings discussed are approximations and are simplified for your basic understanding purposes only, not to calculate the actual loads or forces. We are glad that you're here with us today, and for a quick reference back to this video and others of ours, please click on the red subscribe button below, or just below that, the add to button and create your own playlist. Might I suggest naming one SAR. So let's kick into today's video. One of the applications that we'll use a Prusik loop for is on a horizontal line. This might be used if we are on, say, a steep pitch where we have to traverse across it. Maybe it's snowy or icy and we have a potential of sliding down it. Somebody can set up a rope and then we can use this, grab a carabiner, clip this in and clip this in, and this I can walk across and move. However, if I were to slip, this will lock and I can pull this in any direction and it will hold me so that I don't go sliding down the hill. Then I can simply pinch here and slide it again to keep moving. Another application of our Prusik loops is to be able to ascend a rope. In this case, I'm going to use two different types of Prusiks. One is a standard Prusik loop, and that's what I call a progress capture. So I slide this up the rope and then it holds me so that I don't slide back down. And every time I step up on the rope, it moves me up a little bit more. The second is a Prusik, in which I can take the loop at the bottom, put my foot into it, and snug this around my foot, and I can step up on this to be able to move up the rope. Another application for the Prusik loop is when we're using a litter, in particular in a low angle environment where our feet are going to be on the ground. I can use it to connect myself to the litter. I can wrap it around the litter rails and then connect it to my harness so that when I lift up, all of the weight stays on my harness, which is puts a strain on my body versus me just holding on with a hold strap. So in case my hand gets fatigued, it gets wet and it slips, I don't lose the litter with the patient in it. A second part is I need to also have a secondary connection to our main lines. So a way to achieve that is up front. We have the carabiners at the master point, and I can clip one of the Purcell Prusiks into this that's adjustable, and wherever I'm standing, I can clip that into my harness as my primary attachment point. And then if I need to adjust it to make it a little bit longer, a little bit shorter, I can do that right up there. And again, I can have this to lift up to raise the litter. Another use for Prusiks is to extend my rappel. Sometimes I want to be hands-free, and if I go hands-free here, I'm just going to fall to the ground. So now I've extended my rappel and I've added a third hand so I can be hands-free while I'm hanging out. Another application of our Prusik loops is for use in our mechanical advantage systems. I have two different applications here. One is what we call a progress capture. So as I pull along, I can set these so that I can reset or let go of the rope and move it along, and I don't lose any of the rope that I just took up. It's called a progress capture. The second one is what we call a tractor. That's the part in the mechanical advantage system that moves so that I can go ahead and pull that tension on the rope. We're going to look at how to tie this now. So in all of these applications, it is effectively the same. There are a few different ways to tie this. And when I say ways, it's really just about how many wraps we make. So just to make a definition, this is my Prusik loop, and as I wrap this around, if I were to connect that, that is called a basket hitch. If I take this end of the basket hitch with the carabiner on it, and I pass it through the big loop, that is now called a girth hitch. A girth hitch could also be termed as a single wrap Prusik. It wraps around my rope or whatever I'm wrapping around once. So that's a one wrap Prusik. I can continue to take this and wrap this around again and duck it underneath that loop and pull that up to make a two wrap Prusik. I can continue to wrap this around and slide that through to make a three wrap Prusik. A three wrap Prusik is our standard, and this is what we're typically going to use when we're on ropes. There are applications for a two wrap Prusik as well as a girth hitch and a basket, but those are more of a progression to get us to where we need to be here. So I'm going to go through how to tie this again, this time with a Prusik loop that is tied with a knot and not sewn. What I'm going to do is take the knot end, and I'm going to hold that in one of my hands and take the other end, hold it in my other hand, and drape it over the rope. Then I'm going to pull the knot through that loop that was down here, and I'm going to continue to pass this knot around the rope and through the loop to the number of wraps that I want, 2 wrap or 3 wrap Prusik. Then before I pull this taut, I'm going to grab off to the side of the knot, and I'm going to pull this up so that the knot is not at the peak of this loop. That way when I put a carabiner there, the knot is not sitting on the carabiner, which helps to reduce the load of the loop in that case. One interesting fact about these is when these break, is that when I'm pulling in this direction, this will almost exclusively, unless there's something wrong with the material, this will almost exclusively break on this strand that is closest to the rope where it goes underneath this bridge. And if I pull this way, then it will break on this strand, which is closest to the rope, as it goes underneath the bridge. Okay. On these particular loops, or any of our Prusik loops, we do not want to untie these. So once these are tied, they stay set. And you'll notice that some of these, again, are different lengths. And the reason they're different lengths is, for instance, here we have 2 Prusiks as our progress capture, and we ideally want to have space in between these. So if they're the same length and I set them, then they're going to be right next to each other, which gives a little bit of buffer to it, which makes it slide down the rope. Just as when I put my finger here, I can easily slide it, but when I pull here, it stays. So I need there to be a space between these two, so the sewn ones come in 2 different lengths, as do our tied ones. They'll be 2 consistent different lengths as well. So when we're tying our progress captures, these are all 3 wrap Prusiks. When I'm using a tractor for my mechanical advantage, this is a 3 wrap Prusik. And when I'm crossing a horizontal line, I'm going to use a 3 wrap Prusik. That will get me to the tightening that I want. Now you'll notice that this, I can slide this along pretty easily. The reason that I can slide that along pretty easily is because it's not dressed real well. And what I mean by dressed is that there is no extra slack in these loops, so I'm pulling all of the slack out. Now, as I pull either side, it locks, and then I can simply move it along with my fingers, and I can pull in any direction again. I'm going to give some descriptor terms for this. This part that comes over the end with my carabiner, this is called a bridge. I liken the bridge to coming out and going around to create what I call the wings, which are on the outside of my Prusik loop, or my Prusik hitch as this is. So I have my bridge, I have 2 wings, and then it wraps progressively towards the inside, which then goes down to my carabiner. A Prusik hitch will bind best with a rope with the largest differential between the size of the Prusik cord and the size of the rope that I'm attached to. So for instance, this is an 8mm cord and this is an 11mm rope. That's only a difference of 3mm, which means that this is not going to bind overly well. So I have to make sure that this is really dressed well, and then once it's bound, it's going to stay. If I were to get a 6mm cord and wrap that around here, it would bind a lot quicker and a lot easier, and therefore it would also be harder to release to be able to slide side to side. So that's a benefit, that it grabs a lot better. However, the downside is that a 6mm cord is not rated the same as an 8mm cord. So if I were to have a large load on this line with these progress captures, I might not be able to go down to a 6mm cord. Our standard is using 8mm. Different ratings, and again, this is if it's brand new and if it's tied. So these are all sewn, but if you remember, we had some that are tied. So the ones that are tied, an 8mm cord tied into a loop, a Prusik loop, is rated at 19.5 kilonewtons. Now, when you look at that, you're like, wow, statically that can hold approximately 19.5 people just hanging out on the end of the rope, okay? But this will slip if this were a 12mm rope, which is what all of the tests have been on because that's what firefighters typically use. An 8mm cord, a 12mm rope, this will slip between 6 and 8 kilonewtons. That's a visual indicator for you that you are starting to overload the system. When that slides, we need to reduce the load at the other end. We hope this video was helpful in understanding this component of our rope rescue system. Thank you all for watching the video. Remember to subscribe below to have quick and easy access to all of our videos. We look forward to seeing you in class and out in the field.